Well, heidi ho, neighbor. For those of you who are home improvement fans and used to watch Tim on Tool Time, his neighbor Wilson was kind of ahead of his time. This was the perfect way to social distance yourself in this time of quarantine. So Wilson just knew what was going on all along. But I thought I would kind of start out that way today just for some fun. And also because I decided to social distance myself from my beard for a while. Been a while since I've not had a beard, but I thought it's time to give my face a break. I don't know if I like it better, but it's something different. Just something to make me feel like I did something special on spring break, right? Hopefully you found a way to do something that made you feel special too. But afraid that time's over. We got to get back to some work. So let's see what today's lesson holds for us here. Hey, before we get started, I want to let you know this week office hours. Generally, I try to be online 10 to 11:30 in the morning. Be online for video chatting, questions, anything you got, problems you're having. We can work through them together online. Monday will be different. I will be on in the evening. I'm looking at 6 to 7:30. There will be a posting on Google Classroom with a link you can click, and it'll take you right to my chat room. So look for that on Monday. I'll be, and I'm trying an evening for Monday, and we'll see how that goes. So 6:30 to 6 to 7:30-ish probably. If it changes, just look for the link. It'll be right during that time. Most of the time during the rest of the week, I'm here in the mornings at 10 to 11:30, somewhere around there. But if it changes, just check on Google Classroom. It won't be earlier than that. I would do it later, so I wouldn't surprise you by you missing it. And then Friday, we'll have something a little different now. We're kind of changing since we're going to be doing this longer. We're going to be having lessons on Monday, Tuesday, whichever day is your A or B day, Wednesday, Thursday. And then Friday is just kind of an open day where you can get help, and we'll be online longer. Mrs. Smith also has office hours posted on Google Classroom. So you can click on there, and she's got some tutoring time she's looking at. But you can click on her link as well and visit with her with any problems or questions you have. Either way. So, today's lesson. All right, algebra peeps, let's get this going. Let me get myself out of the way a little bit there. I'm kind of blocking most of the screen. And we will hop on this lesson here. Lesson 10. I better put on the specs. Oh, now I can. Well, hi, how you doing? I can see you a lot better now. Yeah, don't do this near Jamie's. Nah, okay, go ahead. All right, lesson 10, rewriting quadratic expressions in factored form. Part 4, we're getting deep into this now. Which one does not belong? We're starting out with one of those. This is another one of those where there's no wrong answer. No wrong answer at all. So which one would you like to say doesn't belong? What could we say? We could say this one doesn't belong because it's factored, right? None of the others are factored. That's the factors. We could say the second one doesn't belong because it has a coefficient greater than 1. Right? It's got 3x squared. So we could throw that one out of the pack. Or we could say, well, this one doesn't have a middle term, right? It's missing the x term. It has an x squared and a constant. Or this one is the only one that's standard form with a coefficient of 1. It has the x term and has a coefficient of 1. Standard. This is also standard, but has a coefficient greater than 1. And this is also standard. So there's different standard forms, but this is the only one that has a coefficient of 1 and the standard term. So there's a reason we can throw any of those out. Again, one of those wonderful times where there's no wrong answer. All right, let's look at this a little more advanced. We're going to get into some pretty good factoring today. So hold with me. Get stuck anywhere, pause the video, back it up, maybe watch that section again. I hope you're taking notes. Hope you printed out the blank notes if you're capable of it. And just try to follow along. Some of this is going to be a lot easier if you're trying to figure it out on paper also. Okay, each row in the table has a pair of equivalent expressions. Complete the tables, and if you get stuck, try drawing. So we have to give equivalent expressions. There's the factored form. We need the standard form. So remember, we can always do it with the box diagram if we like that, where we put 3x and 1 right there. And x and 4, knowing that the 1 and 4 are positive. So 3x times x is 3x squared. X times 1 is just x. 3x times 4, 12x. And then 1 times 4 is 4. All right, then we put all of those together, 3x squared plus x plus 12x plus 4. We have like terms, so our final equation would look at 3x squared. X squared plus 12x is plus 13x. X plus 12x, and then the plus 4. So that gives us a standard equation with a coefficient greater than 1 on the x squared. So we're going to get into more of that today on how we go the other direction, because that gets a little tricky. 3x plus 2, x plus 2. If you like distributing, we can use a distributive property where you take 3x times x plus 2, and then you take the 2 times x plus 2. Again, we could also do it with the box method. I'm just showing different methods here. So 3x times x is 3x squared. 3x times 2 is 6x. 2 times x is 2x. And 2 times 2 is plus 4. Again, we have like terms. So our completed equation would be 6x plus 2x, 8x plus 4. All right, see where we're getting there? And then finally, our last one, and it didn't matter which way you wanted to do it, you should end up with 3x squared. This is going to be very similar to the first one, but notice the 1 and the 4 have traded places. So this time it's only plus 7x plus 4. And it makes a difference whether that 4 is with 3x or whether it's with the x, because when we distribute, that 3 is going to get multiplied times x, and the 3 is going to get multiplied by 4, which gave us the 12, right? But on this one, the 3 is being multiplied by 1, and then the 4 is only being multiplied by 1x. So we end up with a 3x and a 4x to go together to make a 7x. So it makes a big difference on where we end up here, depending on which one those same two constants are with in the factors. So, all right, let's look at the next page. Are you ready for more? Well, we're about to find out. Here are 3 quadratic equations, each with 2 solutions. So they already tell us that they have 2 solutions for each of these. Find both solutions. Use the zero product property somewhere along the way. Well, that means we need to set it equal to 0 to be able to use the zero product property. Remember, if we have it down to the factors and we set each of the factors equal to 0, it'll tell us what the zeros are, what are the solutions. So if we subtract 6x from both sides from this equation, then we would have x squared minus 6x. Remember, we can't subtract one from the other. They're different terms. And on the other side, it equals 0. Great. Now we've got it equal to 0, but we need to break it out into factors. So we can factor an x out of both of those. So it's the same as x times x minus 6 equals 0. So the solutions are x equals 0 and x minus 6 equals 0. So we'd have to add 6 to both sides. So x would have to equal 6. So the 2 solutions are 0 and 6 on that first one. Either one of those would make this equation true. Okay, the second one, x times x plus 4 equals x plus 4. So we have x times x plus 4. If we subtract x plus 4 from both sides, all right, we'll subtract it, minus x plus 4, and the other side is now equal to 0. Draw a line, don't want to get those together there. Because we subtract x plus 4 from x plus 4, we get 0, and over here we just put it on the end. Now, when we have it in this fashion, we can factor out, we have 2 different terms here. We have an x times x plus 4 term, and we have a minus x plus 4 term. So if we factor out of that and say, I'm going to take an x plus 4 out of it, so we'd have what? Just x there, so plus an x. And then this is negative 1 times x plus 4. If we factor out x plus 4, so it's not really a plus, it's a positive x, but we have these 2 factors, x plus 4 times x minus 1, equals 0. So our 2 solutions be either x plus 4 has to equal 0, in which case x would have to be negative 4 for that to be 0, or, like a minus sign in there. It's not, my plus was really big. X minus 1 equals 0, which means x could be 1. So in either one of those cases, this should be a new the correct equation over here that is true. So let's see. So if we had 1 times 1 plus 4 is 5. 1 times 5 is 5 equals 1 plus 4, 5. Perfect. Negative 4. Negative 4 plus 4 is 0. Negative 4 plus 4 is 0. X times 0. Negative 4 times 0. 0 equals 0. Those are the two solutions for that. So that's the solutions for this one. Now let's look at this. This looks a little trickier. We got a lot going on in this. We've got the 2x times x minus 1, and then we're adding a 3x minus 3 onto that and set it all equal to 0. What can we do with that? Well, seeing that we have this x minus 1 by itself, can we factor it out of this part over here? If we did, this hasn't changed, right? We still have x minus 1 plus, what if we factored a 3 out of that? There's a 3 in both of those. What's left? 3x, if we factor out a 3, so 3x divided by 3 leaves just x. Negative 3 divided by 3. Look at there. Now we've got 2x times x minus 1 plus 3 times x minus 1 equals 0. So since they both have an x minus 1 in both of this term and this term, with two different terms, we can factor the x minus 1 out. And so when we factor it out, what's left? 2x plus 3. There are the two factors, x minus 1 and 2x plus 3. I'm going to highlight those. When we pulled out the x minus 1, it came out here, right? Yeah, not a good highlighter there, but kind of good. Which leaves this 2x and this 3. 2x plus 3. Kind of see those are different colors a little bit. This one's really harsh. I need to stop using that one. So when we factor out x minus 1 from both of those terms, it leaves 2x and plus 3. So that's what's left. That would be multiplied back to get there. So since x minus 1 equals 0, that means add 1, x equals 1. That's one of our solutions. Over here, 2x plus 3 equals 0. Subtract 3. So this leaves 2x equals negative 3. It's not a solution yet because this is 2 times x. So we need to divide by 2. So x equals negative 3 divided by 2. Negative 3 halves. See that? So a little more work, just another step or two, but we can get there with any of these type of equations. Either just simplify like this. Already has the x plus 4. And this one we had to factor the other one out to match that. So let's see where we're going from here. Let's take it another step. We're going to time a blob of water. Okay, an engineer is designing a fountain that shoots out drops of water. You've seen those fancy things, and they try to make them all be in a pattern and something really snazzy like that. So the nozzle from which the water is launched is 3 meters above the ground. And it shoots out a drop of water at a velocity of 9 meters per second. Okay, so we looked at some problems like this before with quadratics. We know dealing with the gravity and everything, we can get an equation, meters above the ground. So function h, they gave us h right here, models the height in meters, h, of a drop of water t seconds. So there's how much time it is. We can figure out how high the water gets as it shot out from the nozzle. The function is defined by this equation. The height equals, the height of the time equals negative 5t squared plus 9t plus 3. And that 3 is our height. It's a constant. It's always going to be 3 meters above the ground. 9 meters per second, 9 per second right there. And this is the effect of the gravity on that one that's they're using for the water. So write an equation that we could use, that we could solve to answer the question. Well, the question is how many seconds until the drop of water hits the ground? What would we need to know? Well, if this is an equation for the height, when is it going to hit the ground? When the height is 0. So our equation would be negative 5t squared plus 9t plus 3 would have to equal 0, the height of 0 meters. That's when it hits the ground, right? When it says 0 meters. Now it says try to solve the equation by writing an expression in factored form, because that's how we know to find that. Like if this was an x, we would factor it out into two different ones, and when is each one of those equal to 0, either one of the factors equal to 0, that's when the equation would equal 0. So it wants us to try to factor this. So we would factor it into two different equations and set them equal to 0. Okay, so we know that the last number has to multiply together to be 3. So there has to be a 3 and a 1. That's our only choices. Or a -3 and -1. Either way, it's still going to be a 3 and a 1. We know our middle term needs to be a 9. So when you add them together to be 9, but we've got this extra coefficient out front of a -5. It's going to kind of play in there. So -5, the only options to get -5 is either -1 and 5 or -5 and 1, right? I mean, that's our only choices. There's not any other two numbers that we can multiply together to get -5. So one of these will be, let's say it's -5, -5t, and the other one would be a positive t. Would that do it? Well, +1 + 1, -5t, when we distribute it, we get -5t squared minus 15t plus 1t plus 3. Well, that leaves us -15t plus 1t. That's not 9t. That's -14t. Maybe the negative needs to go over here, and this will be the positive one. So let's do that. So now this is a positive 15 and a -1. Well, that's still not going to be 9. Something odd is going on here. Apparently, our answer is not going to be a real nice, easy answer to solve. So let's learn what we can do. Here's a way to make it simpler. Here's a clever way to think about quadratic equations that would make it easier to rewrite them in factored form. Okay, let's step through what they're doing here because it's kind of different. So they start with this. I'm going to move this over here in the middle so we can take a look at this. They start with this equation that has a coefficient that's not 1. Right? We have 9x squared plus 21x plus 10. And here's what they did. They took this 9x squared and they said that's the same as 3x times 3x. Or 3x squared. 3x times 3x. 3 times 3 is 9. X times x is x squared. 3x times 3x squared. And over here they said, since I have a 3x here, I'm going to take 3x out of 21x. So if I factor 3x out of that, that leaves 7, because 7 times 3x gets me back to the 21x. And then they left the 10 alone. All right, so now they did something really kind of different. They said n squared plus 7n plus 10. What they've done is we're going to say, let's say n equals 3x. All right, so we're just going to change it to something easier to work with. We're not changing the equation. We're just saying 3x will be the same as n. So n squared plus 7n equals, see, that's the same thing. We just took the 3x, and the 3x became an n in each of those spots. Now, this is something we can factor. We need something that multiplies together to be 10, two numbers, and they add together to be 7. Well, we know that 2 and 5 multiply together to be 10, and they would also add together to be 7, all positives. Perfect. N plus 2 times n plus 5 is the same as n squared plus 7n plus 10. Well, now that we've got it factored, we'll go back and substitute the other direction. We'll take those n's out and put 3x back in. And it says these are the factors of that original equation. 3x plus 2, 3x plus 5. That's pretty nifty. If it worked, right? Let's use the distributive property to expand this and see if the resultant expression is equivalent to what it originally started at. So let's try that. Distributive property. So 3x would have to be multiplied by both of those, by 3x plus 5. And then the 2 would also be distributed to the 3x plus 5. All right, so we've distributed the 3 to both of them, and now we're distributing the 2 to both of them. So 3 times 3x is 9x squared. 3x times 5 is 15x. 2 times 3x is 6x, and 2 times 5 is 10. Like terms, 9x squared plus 15 plus 6 is 21x plus 10. Hey, that equals exactly what we wanted it to equal. So that is actually the factors to the original standard equation. So it says study this method, make sense of what was done in each step, make a note of your thinking, be prepared to explain it. This is just a good chance. If you need to, pause the video, take a look at that. Do you know what happened there? If I gave you that exact equation, could you do that without watching the video? Do you understand the reason what they did? It's just using substitution to simplify it and then substituting back for the answer. All right, it says try this method to write each of these in factored form. All right, so let me set this over here for a moment. We're going to do this. We're going to try one of these in factored form. And I'm going to show you a different method. If this is not working for you, something else you can try, because there's, like most things in math, more than one way to do things. So we have 4x squared and 28x plus 45. We need the factors of that. So let's use the same method they did up here. They had 9x squared, and they said that's the same as 3x times 3x. So we have 4x squared, which would be the same as 2x times 2x, right? Because 2x, 2 times 2 is 4, x times x squared. Okay, and now can we factor 2x out of 28x? Sure, that would leave 14 times 2x plus 45. All right, so at this point is when we will go n will be the same as 2x. All right, we're going to substitute in. So we're saying it's n squared plus 14x plus 45. All right, so we took out those. I'll highlight them there for us. We took out the 2x's and we put in, I did not put in an x. I did not put in an n, I put in a 2x. There we go. Put an x. There we go. Yeah, going to earn me a star for figuring out my problem here. So n squared plus 14n plus 45. Now, can we take that and find two numbers that would multiply together? So I need it to multiply together to be 45, and I need it to add together to be 14. This is multiplying, this is adding. So what numbers multiply to be 45? We've got 45 and 1, 15 and 3, 9 and 5. Let's see, which ones of those would add up to be 14? Oh, well, 9 and 5. 9 and 5 would multiply to be 45. 9 and 5 would add to be 14. So this must be n plus 9 and n plus 5. So if we substitute now, we can go substitute back. We have this down to a simple factored form. So since n equals 2x plus 9 and 2x plus 5 would be the factors of that standard equation. Okay, kind of understand that. That kind of works. If we have something we can pull out of both of those, like the 2x works well in both of them. Now be aware that most quadratic equations really don't factor. Where you're looking at special ones that do, but there's a lot of quadratic equations that you will not be able to factor out to something so simply at all. You'll get into some really odd numbers, and it doesn't work so well. But we're giving you ones that do factor, just trying to figure out a good method for that to work. So, talked about another way to possibly do that. It would take a little more guess and check if you're not understanding how that's working. A little more guess and check. But going back to our original method that we were going the other direction, we were using the factors to find the standard. I wonder if we can go backwards and do the same thing. We know that this number would be a 6, and we know that this would be a 25x squared. All right, and we want to be a negative 35 with these two added together, negative 35. So if this is going to be a negative, and this is going to be a positive. There's a chance these will both be negative numbers, but one of them is going to be multiplied by something pretty big, perhaps. So let's see. I would start out, and like I said, we got a few options for 25. It could be 5 and 5, or it could be 25 and 1, right? It could be either one of those to get 25x squared. Let's start with just 5 and 5, because we think that'll work. 5x and 5x. So I'm guessing what the factors would be. I'm guessing the factors of 25 would be 5 and 5. So it'd be 5x times 5x would be 25x squared. That is a squared. All right. So here I need two different x's that will add up to be negative 35. Let's see what for 6, and knowing this is a negative 35, these are probably going to be two negatives. If this was a positive, I know it'd be positives would be fine. But for 6, we've got negative 2 and negative 3 would multiply together to be 6, or negative 1 and negative 6 would either one. So let's try it with the 2 and the 3 first. So if this was a negative 2, this would be 2 times, negative 2 times 5 would be negative 10x. And then this would be negative 3. So 5 times negative 3 is negative 15x. Well, what did we get? We got negative 10x and negative 15x. And when we add those together, we did not make it to negative 35. So perhaps that is wrong. Let's try this instead. Let's try negative 1, negative 6. Okay. Like I say, this method takes a little more guess and check. But if you're not totally not understanding the other method, I want you to have some way to solve this. So let's look at negative 1 times 5x would be negative 5x. Negative 6 times 5x would be negative 30x. Negative 5 and negative 30 would add together. So this must be our two factors. We have 5x minus 1 and 5x minus 6. That would be the factored form of the same equation. Like I say, more guess and check. If this would not have worked either, if negative 1, then I know this one's wrong. And I'd have to go back and change this to a 25 and a 1, and then try both of them again. That's where this gets to where it can be a lot more lengthy if there's multiple options. 25 was nice. It only had two different options. But if we had a number like 24, it could be 24 and 1, it could be 12 and 2, it could be 8 and 3, it could be 6 and 4. We could end up checking a whole lot of combinations doing it this way. But it does provide another way if you're not understanding exactly what they're trying to do here. Okay, so I want you to have that option. Let's look at this last page. All right, you've probably noticed that the coefficient of the squared term in all the previous examples is a perfect square. Right? We had the 9x squared, so it was 3 times 3. We had 4x squared, it was 2 times 2. But what if that is not a perfect square? Which most would not be. So here's an example of an expression whose squared term has a coefficient, not a squared term. 5x squared. 5x squared. We can't take a number times itself and get 5 unless we get into some irrational numbers, square roots, different numbers. So here's a method that does this, and follow along here. This may be another place you want to review the video. It says, since this is 5, I'm going to take this whole equation and I'm going to multiply it by 1, right? If I multiply by something by 1, it doesn't change. And this is how I'm writing 1. 1/5 times 5. 1/5 times 5 is the same as 1. So if I multiply this equation by 1, I'm not changing the equation, I'm just changing how it looks. So then it took this 5. So they took that 5 that we see right there, and they distributed it into the parentheses. And they left the 1/5 out front. And they're leaving the 1/5 out front for a long time here, right? So we're not doing anything with the 1/5. 1/5, so 5 times 5x squared is 25x squared. 5 times 17x is 85x. 5 times 6 is 30. We took it and distributed the 5 into it. Now, they're using the method that we did with the perfect square. We created a perfect square by multiplying 5 times 5. So we know 25x squared comes back to 5x times 5x, or 5x squared. And then we were able to also pull 5x out of here because we knew a 5 would go into it because we multiplied 5 into that also. So 5x squared plus 17, you knew 17 times 5, 17 times 5x plus the 30. Now we're using the n equals 5x, making this n squared plus 17n plus 30. This is something we're able to factor. We found 15 and 2, multiply together to be 30, but add together to be 17. Okay, since we got to this, we'll go backwards and we'll take the n out. We put the n in right there, and we're taking it back out. We'll get down to here. Instead of n, we use 5x. Instead of 15, we still have the 15. N 5x, 2 is 2. Now we still have this 1/5 up front. We need to multiply it back in. And we only have to multiply it to one thing. If we have 2 times 3 times 4, if we're multiplying three things together, we're not multiplying 2 times 3 and 2 times 4. We're multiplying 2 times 3 times 4. So that's what they're doing here. 1/5 times 5x is x. 1/5 times 15 is 3. And then that is not changed. So these two factors are the same as the standard form right here. Can be tricky to guess that sometimes. The 3 and the 2 gave us the 6, and then you had to figure out where does the 5 work, which one goes best with that. All right, so let's use the distributive property to expand that and make sure that it's equivalent, like we did on the other one. So x plus 3 and 5x plus 2. So I'm going to distribute the x to the 5x plus 2 plus the 3 to the 5x plus 2. My pencil's getting a little dull here. So 5x times x is 5x squared. X times 2 is 2x. 3 times 5x is 15x. And 3 times 2 is 6. Like terms. So it's the same as 5x squared plus 2 plus 15, 17x plus 6. Perfect. Excuse me. All right, study this, make sense of what's done. Make sure you understand why. And then try that method to write each of these in factored form. All right, I'm going to do one of them. And then I want you to try the other one, just on some scratch paper or whatever. See if you can figure out how to do that one the same way. And then if you have any questions, get on the online chat I got. But let's do the same thing. Since this is a 3, we're going to multiply it by a 1/3 times 3. All right, otherwise we're not changing anything yet. We're multiplying the equation by 1. And we're writing 1 as 1/3 times 3. So now we're going to take the 3 and distribute it. So 1/3 times 3x squared. 3 times 16x, and 3 times 5. All right, we're going to rewrite that. 1/3 times, this is 3x times 3x, or 3x squared. We can factor a 3x out of that also. We know it's 16 because it was a 16 before we multiplied it by 3. So if we're dividing it by 3, we know it's still 16 times 3x. Plus the 15 that we left there. Now we will substitute n equals 3x. So this is 1/3 times n squared plus 16n plus 15. Okay, what two numbers would multiply together to be 15 but add together to be 16? Well, our only choices for 15 are 3 times 5 or 1 times 15. Which of those would add together to be 16? That one's not too difficult. It's got to be n plus 1 and n plus 15. 1 and 15. That's the one we want because they would add to be 16, multiply to be 15. And still times 1/3. Let's substitute that back in. So 1/3 times 3x plus 1 times 3x plus 15. Now, I'm going to take this 1/3. I can multiply it by either one of them, right? Because up here with 2 times 3 times 4, I can do 2 times 3 first and make 6 times 4. Or I can take the 2 times the 4 and I can make 3 times 8. All right, I can multiply the 2 times either one of them. When I look at this and I'm multiplying 1/3, it's going to be easier to do it by this one because both of these numbers are divisible by 3. So I'm going to multiply, I'm going to leave the first one alone. I'm going to multiply 1/3 times 3x is x, and 1/3 times 15 is 5. There are my two factors, 3x plus 1 and x plus 5. Okay, you could have multiplied by this one and got x plus 1/3 and 3x plus 15. Those are also two factors that work for that equation, but these are cleaner and nicer to look at, right? So, all right, try this one on paper. I will probably post later just an answer to that, but I want you to try, give it a shot first. And then you do have some homework problems that will be, so, all right, try this one on paper. I will probably post later just an answer to that, but I want you to try, give it a shot first. And then you do have some homework problems that will be on Google Classroom also on the same link. So click on the Go Formative and it has some problems for you to work there. And I will be online for office hours. So catch me this week. And don't forget, we're online. Mrs. Smith and I are both online at different times or sometimes even overlapping times. But we each have our own video chat room where you can get help. So if you're having any trouble with any of this, please check with us. And I hope you're having a good time doing this online, not having the distractions of school. Hopefully you've got yourself a place where you're working and can focus on your work and get it done and not have to spend 7 or 8 hours like you are at school. You can wrap it up in less time if you're focused and just concentrate on your work. So do work you can be proud of. Have a good day.